On page 16, the oral exercises, number 1 asks for the additive inverse of 3. Additive inverse is another word for opposite, meaning the opposite sign. So the opposite of 3 is negative 3. The question also asks for the absolute value of 3. Absolute value is the positive distance from 3 to 0 on a number line. That's 3 units. Number 7, the additive inverse of negative 1/5 means the opposite of negative 1/5. That's positive 1/5. The absolute value of negative 1/5 is also positive 1/5. For number 11, the first thing to do is simplify the number they give to you. The negative of negative 2.5 is 2.5. Now find the additive inverse, negative 2.5. To find additive inverse, you change the sign of the number. Then find the absolute value, and that answer is 2.5. Absolute values of numbers are always positive answers. Number 13 asks for a reciprocal. The reciprocal of a fraction is when you turn the fraction upside down, 8/5. Number 15 has no reciprocal. 0 is the only number that has no reciprocal. So the answer is none or empty set. For number 17, to help us find the reciprocal, we could write this as a fraction. This is 1/10. Now it's easier to see what this would look like when you turn it upside down. 10/1, or simply just 10. Number 27 is a true or false question. The absolute value of negative 3 equals positive 3. That's true. The absolute value of a negative number is a positive. Number 35 is the negative of negative a equal to a regular a. That's true. Number 29, negative 3 is greater than the absolute value of negative 10. Let's rewrite this. Negative 3 is greater than 10. That's false. Number 33, is 1 over negative 1 times 2 equivalent to these two things times together? Yes, it is. That's true. For page 18 written, number 1, we're asked to solve this absolute value equation. What number could go inside the bars? One possibility is 6, because the absolute value of 6 is equal to 6. The other possibility is negative 6, because the absolute value of a negative 6 is also equal to 6. Number 3, the opposite of x is equal to 4. So what's x? Well, x would have to be negative 4, because the negative of negative 4 is equal to a 4. Number 9, negative s plus 2 equals 0. This number right here has to be negative 2, because negative 2 plus 2 makes 0. So what's the s have to be? The s would have to be 2. Number 11, this right here has to turn out to be 2, so that 2 plus 1 makes 3. So what could the x be? The x could be a 2 or a negative 2, for the same reason as what we discussed in problem 1 above. Number 17, graph this absolute value inequality. Remember earlier we said that the absolute value of any number that's not a 0 is always a positive answer. There's no way that this absolute value can turn out to be less than 0. This has no solution, so we're not going to put any dots or do any shading at all on the line. Number 19, the negative of r is less than 1. Let's solve this equation by dividing both sides by negative 1. When you divide by a negative number, you switch the arrow symbol. R is greater than negative 1 is equivalent to the original inequality. To show this answer, find negative 1, put an open dot, and shade in the numbers greater than negative 1. Number 23, let's graph the absolute value of p is less than or equal to 2. absolute values that have a less than symbol are equivalent to this compound inequality. Find -2 and +2. Put a closed dot on both. A closed dot because of the extra or equal to part of the symbol. And the letter P comes in between there, so shade in between. Finally, number 27. The absolute value of t is greater than 0. Remember earlier we said that the absolute value of any number will always be greater than 0, except for the special case of 0. So let's find 0, mark it with an open dot, and then shade everything to the right and everything to the left. Discussing this graph a little bit, one of the numbers to the right that we shaded was, let's say, 4. Do you agree the absolute value of 4 is greater than 0? So it makes sense to shade to the right of the 0. One of the numbers to the left of 0 that we shaded over is, for example, -4. Do you agree the absolute value of -4 is greater than 0? The only number that should not be shaded is 0 itself, because the absolute value of 0 is not greater than 0. It would be equal to 0.